Okay, so we were talking about what to do with the sequences, what kind of applications you can have. I'll try to give a brief idea about what type of problems we solve using sequences. Classifying, for example, given a sequence, what kind of, what category of a sequence is. I'm going to give you examples now. Or predicting the sequence next value, or transforming a sequence, just like translation, Turkish text sequence being translated into an English text sequence. Compare two sequences, given two sequences. We're trying to understand the meaning out of it, similarity, maybe. And you can do generation, but as you can see, there's a red cross here, although there are green check signs for the other ones, because generated models will not be a part of this course. So we will leave it out of the scope of this course. We'll make a gentle introduction to give you an idea, but we will not delve into them. That's another world. Okay, so for example, let's begin with sequence prediction. Sequence prediction is, given a sequence, we have a model, which is the function f. You're provided y of t, which is the next value. So what you do is you observe the sequence's history and you predict the next value. It could be, the sequence could be anything, a number, a text, a language, whatever, characters in a text, or a sequence of products bought by a customer. This is a very common problem being solved in the industry. Observe logs, frames of a video clip, doesn't matter. You're trying to predict the next label, the class label, or a sequence. So what you do is predicting, it could be predicting the next value, it could be predicting the next category, or it could be predicting the sequence itself, whether the sequence is the value of the sequence, maybe like the first example. So this is simple. The next value problem is, you see these, I see these all the time in Facebook. That's a sequence prediction problem. And actually, we have this a lot. For example, I have given a stupid example saying Facebook, but stock market is a very nice example, and people earn millions of dollars out of it. Or the Bitcoin price. Actually, I'm sure that there will be one of you who would try to implement the historical Bitcoin data or Binance data, multiple Bitcoins, to predict the next value of Bitcoins. People tried it because I've given a similar course in my previous university. There were people who tried Bitcoins. Be my guest. I did, by the way, I'm not making fun of it. I did try it myself, and it's quite chaotic. I mean, the type of feature engineering or the type of model you try to implement, they are very difficult problems. So I strongly recommend. It's a very difficult problem, but it is not easy to fix. I mean, and I'm not sure if somebody finds the solution, they would present it. I mean, would you present it? Because if you found the solution, send us a nice card from a tropical island. Don't send the project, Omar. We will understand. We will understand. Don't worry about it. Okay, I continue. The next value problem, it could be multidimensional, because there could be relations between different sequences, so multi-sequences prediction problem. Or a sequence problem is something you always do. For example, Google's auto-completion is maybe the best real-world example, and it's an LSTM, by the way. How do I know this? Because the founder of LSTM, a famous guy, Jürgen Schmitthuber, we are going to talk about this guy. He's a German guy who have come up with the idea of LSTMs. In one of his speeches, he mentioned about this example, because apparently his paper was rejected when first applied to NIPS in 1996. And he says, if for every Google search you're using it, and it's a fantastic example. When you write something, next word is Google tries to predict your next word according to the searches of the world and according to your searches. For example, this is one of my searches, guys. I specifically did this for this slide. I have written Star Wars sequel trilogy is, and the first thing that came is bad, disaster, not canon, garbage, mass, trash. And the first positive one was canon, was the last one. Try it at home. If you don't hate sequel trilogy, just like I do, you will have different results. Because according to your search result, something is already saved. So it provides personal experience to you. That's how it keeps an LSTM, which is trained every time you search something and every time people search something. So it's a like good mix. There are countless real-world examples, guys. Sequence prediction is all over the world, and actually the industrialization of sequence prediction is nowhere near being complete. I mean, if you're working in a company, that is definitely, I assure you, a sequence prediction problem in your company that is to be solved. There should be, and impossible that, I don't know, even if you're just administrating a small market bakkal, even there's a sequence prediction problem, okay? Anyway, I continue. Sequence classification, which is a bit different. We find the category of it. For example, we are given some numbers. We say that this is not a correct one. We give an alert, so like anomaly detection. And there's at least one of you working on that subject because Mert is my student. He's taking this course. He's trying to understand if there's an anomaly in bank transfers. Well, that's a very nice example. And there are, again, countless real-world examples. For example, fall detection in elderly. I had a paper like that using conventional methods. But imagine there's a camera watching you all day and there's an embedded system in it which runs the sequence model, deep learning model. It tries to understand if something bad happened to you. You're an elderly person and you're alone. You just fallen and fainted. We need a detection system for that. It's very difficult. And the existing systems doesn't work. I'm saying this as a person who has done research on that. Very nice real world problem. Incredible number of problems. I mean, sequence modeling is, as I told you, nowhere near to be complete in the world. We'll have many problems to solve. For example, topic category, not only animal detection problems just falls into this part of the problem. So topic categorization. So is this a news article? Is it a food article, sport article? Sentiment classification. People write comments. Is it a good comment or a bad comment? Just by checking the text, I try to understand it. Okay. And the animal detection, of course. Well, one of the most important ones. That could be something else. For example, the input doesn't necessarily have to be a structured data. It can be something like it's a power network and you're observing the signals. So you have a CNN plus RNN architecture which would detect an anomaly because there are ripples. But is this an important ripple? I don't think that there are power electronic systems that use sequence modeling, another open area. Well, I'm imagining this could be some ideas maybe related to your field for your projects. And if you're doing a project which will be related to your thesis, I hope that it will make sense, I mean, as a part of your thesis. I definitely hope that because it motivates you in your thesis. Okay, and genomic research, another one. Genomic research, people are working on is classifying protein sequences into categories because they are a bit difficult to process. We don't know in a DNA sequence, we don't know where a certain chromosome starts and ends. It's difficult to understand. And people do sequence classification to label if that chromosome exactly exists or not. So RNNs and not, people are working on this. Very recent problems, guys. Everything I'm telling you right now is less than 5 years old. Health informatics, actually we have a department for that. They are switching to sequence models in an extreme speed because, okay, the first example I've given, I had some lab results. By judging the lab results, the practitioner decided on something. And when another patient came, he forgot about my results. However, I have a sequence of lab results belonging to me. Maybe something that they couldn't see in a single lab result would make a meaning in a sequence of lab results taken in the last 3 years. And observing that data, maybe we will find an early classification for a specific disease. Maybe some sort of diseases will make them recognizable in sequence of lab results beforehand. Yeah, quickly just working on this. Or one of the examples is actually, it's a very common example, ECG signals, you know, the heart signals. It's difficult to process. I mean, you have to be an expert to understand if there's a problem in your heartbeat signals. And only the expert people can understand it, but there are very recent algorithms using LSTMs that can do this actually, guys. This is so common that this specific example would not make a project because it's already been done. Let's continue. Another type of problem in sequence modeling is transformation, which we call sec to sec, sequence to sequence. So we have a sequence, we turn them to other sequences. So this is a mathematical example, which doesn't make sense, but the simple example that makes sense is language translation. He loved to eat, liebte zu essen, from English to German. Since from language to language, the grammar changes, your model should be able to transform the semantic to a new grammatical structure. So that's what the sequence-to-sequence models do. And we'll deal with sequence-to-sequence models a lot because actually the sequence-to-sequence models, this is a recurrent encoder-decoder model, which we'll be seeing in week 6 or week 7, led us to the idea of attention and where is the attention in the sentence, or these models are applied not only to language translation, to video understanding, to video captioning. Video captioning is a nice example. There's a video and there's a text explaining that video. A cat is walking on the wall, kind of. Still, we have these models. They are sequence-to-sequence problems. And actually, the state-of-the-art architectures like transformers, they are sequence-to-sequence architectures. Good. What to do until next week? Prepare your environments. If you have taken an introductory level deep learning course, I'm sure you already have an environment. Check the additional reading page for references, and more importantly, think of a project idea, and preferably related to your thesis. You don't know it, do a Google's research, but first think about your thesis. Maybe you haven't realized it, I'm sure you did, but your thesis at its core has something quite dramatically related to a sequence problem. I wouldn't imagine any other type of problem in informatics, guys. If you have a problem in informatics, that is 99% related to a sequence model. Find that problem, try to work on it, Google it, check what people have done, check for available data sets for this sequence problem. Or if you have come some road so far and you've done things, think about how you can implement it. Think about your data. So it is time to talk about your project and data. And next time you see me in classroom, because it will be hybrid and we'll be in class, talk to me, or in Zoom. It will be in Zoom as well if you want to join it in Zoom. Talk to me. I have a project idea like this. I want to do this. Okay. So in this course, there is no teaching assistants. So nobody is going to collect your project proposals. You will directly tell me your ideas, and we are going to discuss this in class. And please discuss them openly and publicly in class so that people will, somehow learn from each other. Okay. Okay. So this is your. What we're going to do next week, we are delving to deep, not deep, recurrent neural networks. Yeah, we're going to get to the formulation of it. What makes a recurrent neural network recurrent? We're going to talk about states. We're going to talk about hidden states. And in the following weeks, we're going to continue with gated units, LSTMs, bidirectional recurrent units, and deep RNNs, and many more. Okay? Check the additional reading references. And before I finish, guys, this is our Auto class page. So in the Auto class page, there are lecture slides. I'll provide the lecture slides here. You can check them. This is the first week. I'm going to upload them. This is the Zoom lectures link. So if you somehow lose it, this is the Zoom lectures link. You have it in announcements, but this is here. And this is the YouTube lectures playlist. If there's no problem and I can record the class, they will be here. But if there is a technical problem and I cannot record it, I'm sorry. For those lectures, you won't have them here. But I will always try to record. So I guess there won't be a problem. Okay. See you next week. Have a nice weekend.